Hello and welcome. Today we're doing a question from LeetCode. It's called search insert position. It's an easy. We are going to jump right into it. So given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O of log n runtime complexity. We have a sorted array and we want to write an algorithm with log of n runtime complexity. These are sort of dead giveaways that we want to be performing a binary search. So example 1, we have our input nums 1, 3, 5, 6, and we're looking for the target 5. We do spot it and it's at index 2, so our output is going to be 2. Example 2, we have that same array 1, 3, 5, 6, and we're looking for a target 2. It doesn't exist in our input nums, so now we want to return the index of where it would be if it were inserted in order. Now we know it needs to be inserted in order. What does that mean? It means all the numbers before it need to be less than that number. So it would be inserted at index 1 over here. All the numbers before it would be less than our target. And example 3, we have 1, 3, 5, 6, that same array, and we're looking for 7. It doesn't exist. But if we were to put it in the array, where would it go? It would go after all of these numbers because it's greater than all of these numbers. So it's going to go at index 4 that doesn't even exist in our array yet. So it's 0, 1, 2, 3, and then it would go in index 4 over here. Okay, so how are we going to solve this? First, we want to be very clear for what we're exactly looking for. We know we are looking for a target, and if it exists in our input nums, we want to find the index of that target. If it doesn't, we want to find an index right after all of the numbers that are less than our target. So we want to find that first index that has a value greater than our target, because that's where we are going to be inserting our number. And if we look back to example 2, right, where would we have inserted target 2? We would have inserted it at position 1, where the number is 3. And for example 3, where would we insert 7? We are inserting it after all of the numbers that are less than it. So we're going to be inserting it at position 4. Now that we know exactly what we're looking for, we can just perform a binary search. Now, if you don't know how to do a binary search, it's actually fairly straightforward. We always want to start off with 2 variables, our range, so it's going to be low and high. What we want to do is we know we want to search within this range and it's sorted. So what we're going to do is find some midpoint in this range. Once we have a midpoint, we're going to see how it compares to the target value we're looking for. And based on that, we're going to be adjusting our range. We're either going to be bringing low in towards the middle or high in towards the middle, cutting our range in half every single time up until our 2 variables converge in the middle. So how would this look like coded up? Say we are dealing with example 1 again. So I have my input 1, 3, 5, 6, and my target is 5. What is my range going to be? What are all the possible outputs I could have? Well, that's going to range from index 0 to index 4, right? It could be after whatever we have in this array. So my low and high variables are going to be at index 0 and 4 respectively. So low and high are going to be 0 and length of nums. Now we're just going to keep slicing our range in half every single time up until the variables converge. So our while loop is going to be while low is less than high. At this point, we want to find what the middle is. So mid is going to equal low plus high, integer divided by 2. So low is 0, high is 4. Adding that together, we get 4. Integer dividing that by 2, we get 2. So mid is at 2 over here. Now we want to see what the value at mid is and how it compares to our target. We're going to have 3 options. Either the value is going to equal target exactly, at which point we can just return. We don't need to keep looking in our array. So if nums of mid equals target, we are just going to return mid. Mid is going to point to the index that is going to equal target. And in this case, it does equal target, so we would have just returned out of here. But say this wasn't 5 and say this was 4 instead. So what are our other 2 choices? If we don't exactly equal target, we're either less than it or greater than it. So elif nums of mid is less than target, what are we going to do? If we are less than target, in this case we are, right? 4 is less than our target 5. We want to move low to be mid plus 1. We know for sure the index we are looking for is going to be after this midpoint. No index from mid all the way back to 0 is actually going to be what we're searching for. We're either going to search for our target value exactly or look for a number that is just greater than it, right? If we wanted to insert something, we're looking for that first number that's greater than our target. We're never going to be looking for something less than our target, which is why we can move past our midpoint if our nums of mid is less than target. So if this is the case, we are going to set low to be mid plus 1. And over here, that is the case. So what is low going to be? Low is going to be index 3. Now, if this wasn't the case, what would we do? We know nums of mid would be greater than target if we don't go in either of these conditions. So in this case, we want to move high down to be mid. We're not moving it down to be mid minus 1 like we did in low. We're moving it to be exactly mid, because that could be an index we are looking for. We could be looking for a number that is just greater than target. So we want to include this in our range. When we were at low, we didn't want to include anything less than our target, but if we are above our target, that is something we want to include. So high is going to move directly to mid. Now, this is everything we need in our while loop. Once we exit our while, low and high would have converged. So we just want to return whatever index they've converged on. They point to the same thing, so it doesn't matter whether we return low or high. So we're just going to be returning low. So let's go ahead and submit this. And it is accepted. Now, the runtime complexity of this, since we are doing a binary search, is going to be log of n if we have n elements in our list. And for space, we're only keeping track of low and high and mid here. So it's going to be constant O of 1. It has no dependency on how big our input gets. It has no dependency on n whatsoever. So now that this is submitted, let's actually finish running through our example just so we can see how our code is going to run line by line. We had last finished off in this elif condition. We had moved low to be mid plus 1. So we want to go back in this while loop. Low is still less than high, so we can go in here. And so we want to calculate a new midpoint. Low plus high, integer dividing that by 2. So 7 integer divided by 2 is going to be 3. It's 3.5, but we don't care about the decimals. So mid is going to be index 3. It points to the same index as low. And we want to make a check. Nums of mid. So nums of mid is 6. Does this equal target? It does not. If nums of mid, is this less than target? 6 is not less than target. So we go in this else and we want to move high down to be mid. So high has now moved down to 3. They all point at index 3. So now we can't go back in this while loop. Low and high have converged. Low is no longer less than high. And we're just going to return low, which points to index 3. And this correctly points to the index of where we wanted to insert our target if we were to add this in our array. So we just went ahead and solved search insert position. If you have any questions with this whatsoever, let me know down below in the comments. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next one.